Okay, sets, and we'll continue with that discussion. Sets have to be well defined. If we would say the best baseball hitters, that would not be a well-defined set because different people would think different people were the best hitters. Or if we talked about the best movies, that would not be well-defined a set, so it would not be clear. My definition of best movie may not be the same as yours, okay? But we could make it more specific if we said movies that received Academy Awards, some or any Academy Awards, okay? That would be a set of movies that we could go back over the history of the Academy Awards. It might be a big number, but movies that had either actors or directors or special effects or some Academy Award that was won, that might be in the set. And if you define it clearly, that could be fine, okay? So different people would get the same results having done careful research, okay? So we'll see different problems in the book that are interesting, and they just practice that concept. Okay, let's go on here. Okay. Now we have something called the universal set. Okay, the universal set is the set that includes all elements. Okay, if I have a set A that's defined as 1, 3, 5, 7, and the set B that's defined 2, 4, 6, 8, okay, the universe would be all of the elements that are in either or both groups, okay? And just to make it interesting, let's have some elements that are in both. Okay, we'll put 9 in both. Okay, so that's a roster of set A, that's a roster of set B. So no, that is not just all the even numbers between 2 and 10. It's actually got an odd number here, so you got to look at the rule and look for exceptions. Okay, so we have 2 rosters for 2 different sets, but the universe would be all of the elements that are either in one or the other or both. So that would be the 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, that's the universal set. That's the set that these all come from. Okay. And there's also something called the null set. And the null set is the set that has no elements in it. It's empty. It's an empty set. But it is a set, nonetheless. Okay? So the symbol 0 with a line through it, that represents the null set. Okay? And it is the empty set. Okay. I'd like to talk now about subsets, okay, because that comes in handy, and you'll see those words used in the problems that we're going to do in the book. Okay, if this is the universe, or the universal set, all the elements, A is a subset of the universe. Every element in A is also from this group. B is a subset from this group, okay, because all of the elements in B come from this group. So it's a subset. And the way we write subset is A is a subset of U. Okay? So it's a subset. It's from that set. Okay? The null set is also a subset of the universal set. It's this set with no elements. That may seem a little bit funny, but if you think about it, 0 is one of the numbers, correct? If you look at the number system, 0 represents a quantity of nothing. It is not nothing, but it represents 0. If you went and put oranges in a basket and collected them, Somebody may have 5 oranges, somebody may have 10 oranges. You might come up with an empty basket, so the number of oranges you have is 0. Okay, so let's talk a little bit about subsets.